Doug, you come from a background in computer science, AI, robotics. I'm wondering what or if this concept of experimental protocols exists in those fields and how you've seen them be used.
Yeah, that's an interesting question. And I must admit that I've worn a very different hat from Tiffany over the years. The area that I worked in as an academic in research, as you mentioned, was this area called developmental robotics. And it's really a crazy idea that you want to have this. It could be a robot or it could be just an agent of some kind, but you want it to have its own self-motivations, its own desires, its own ability to make decisions and go off and explore things. And some of the ideas of protocols in general, experimentation in general, don't fit neatly onto perhaps many different kinds of machine learning problems that people are working on. Not everything can be seen as just a set of data and you feed it in and you get a particular set of answers that you know that you want or you don't want. Sometimes you could have a system that's, well, perhaps in the future, we don't see a lot of this today, but you could see that these machine learning systems could be much more creative than we're allowing them to be today. So the question of how these protocols fit onto those kinds of experiments is really interesting. Not even about reproducibility, which is a hard problem, and we'll talk more about that, but just like coming up with like, what's a baseline? What are you comparing to? It reminds me of a story a few years ago. I was working with some students and we were exploring the idea of memory. What kind of memory does a neural network need to have to solve different kinds of problems? And we set up a problem, a robot to go down, so a light would come on at the end of a hallway. The robot would have to remember what that light was, red or blue, go down the hallway, and then turn left, it was red, turn right if it was blue. We thought, let's come up with a baseline of where we wouldn't give the robot any memory at all. And then we'll explore different kinds of memory as we go forward. So we set up this neural network that was a reinforcement type machine learning scenario. And we trained it up, and amazing to everyone, the robot was able to solve the problem without memory. So we specifically designed a problem that required memory to solve, and the robot was able to do it. And of course, the machine learning system was able to do it without memory. We explored this. How could that be? This was supposed to be our baseline. It was not supposed to work, so that when we do add memory, we can compare that favorably in a way and say, see, you need memory. And then we could explore what kinds of memory. But when the baseline works pretty well, we were left scratching our head, what do we do? It turned out that, like a lot of reinforcement learning systems, they can solve the problem in ways that humans don't think about. And it turned out the robot was solving the problem by, when the light would come on at the end of the hallway, it would immediately turn left or right instantaneously. And then it would just follow the wall. So if the light came on, it was red, it would turn to the left a little bit and follow that wall and then turn left. So it was able to use the world as memory. And so, of course, this is well known now. It's called embodied intelligence, or there's even a nice book called The Extended Mind. But it's really a big picture about how machine learning systems and brains can work in the real world. Yeah, I think when we look at machine learning in the big picture, oftentimes we have to adjust what we mean by these different protocols, whether it's baseline or reproducibility.